In this video, we're going to pick up where we left off in this time series analysis notebook related to the Building Data Genome 2 project. So far, we've learned how to load the data as a time series index, how to manipulate that index, pull out different types of information related to the timestamp. To get started, we'll go ahead and create, once again, a meter example by pulling out the building meter called Panther Education Jerome, which is an electrical meter. So let's go ahead and run this. We can use .plot, of course, to plot this. And the default plot, of course, is line chart, as we mentioned before. And what happens here, you can see the behavior of 2 years of data from this particular meter across this time span. It looks like for most of 2016 and all of 2017, the data has a certain type of behavior. But in the very beginning, you have this flat line, you have an outlier. You can see really how messy this data is. But the thing, and we'll learn in a second how to deal with that, but the thing I want you to understand quickly is that because of that date timestamp, the x-axis label is quite nicely formatted in a way that very easily allows us to see the date time range very easily. If we, of course, can change attributes of the .plot function, just like we learned previously with bar charts, we can change the marker, the line weight, the line style, and the size of the figure very easily using those attributes. One thing that I find very useful, this is a function that is extremely useful with time series data, is a function called resample. Resampling is where you're taking the frequency of the data and changing it. Resample down or up allows you to change, let's say, in our case, hourly data to daily data, monthly data, annual data. So you're basically rolling up data and aggregating it in a certain way. And you can aggregate data in using mean or median or sum or any other type of aggregation across those time ranges. This is something that I've showed this function to people who've tried to do this kind of thing in Excel and have spent days or even weeks trying to figure out how to do it, maybe with Visual Basic or some sort of fancy functions, or I guess you call them equations in Excel. But you can do it with literally just one function, one line of code very easily. So if we go back to our original data set with the timestamp, we'll look at the top with the dot head, you'll see that there's a timestamp here, and that timestamp has every hour. So midnight, 1 in the morning, 2 in the morning, 3 in the morning, etc. So using .resample here, it allows us to, if let's say we want to resample to daily data, we would use D as the indicator of daily data. And there's a library of the symbols for these different aggregations on the Pandas website. And then we're using the function .mean. So we're telling it to resample based on daily data, and we want to average across those days. So each 24-hour period will be taken the average or mean across that, and that's the result you'll get. So if we run this real quick, very fast, and then we can see very quickly that this new data frame underscore, basically the same thing as before, underscore daily dot head. The first 5 rows are January 1st, 2nd, 3rd, 4th, and 5th. So you've rolled up a bunch of data. Each of these timestamps indicates that there's 24 hours of data that was averaged across that time range. So very fast and easy. Yeah, it's magic for people who usually do things like this without using Python and see it done very quickly using Python. So if we make a plot of this, you can see that you saw the same type of behavior. Some of the outliers have been averaged out. You can see the behavior here at the beginning. Of course, the flatlining doesn't change, but it's much smoother. You're essentially, when you're resampling, you're averaging and you're really smoothing the behavior of the data set. You'll notice that I created a new data frame when I did that resampling. I underscore daily. This is, you've seen this throughout the last few videos. I like to do that because these are not huge data sets, and just making a new version of whatever transformation you have allows you to also call back that old version to redo something or to create a different transformation if you'd like to. But a lot of people also like to overwrite their original variable names as well, which is fine. And this is probably good practice if you have very large data sets which use a lot of memory. We can also do monthly data. So down here you can see that we'll do the same thing, except we will be resampling with a capital M for monthly. We'll also be taking the average. And here we've chained all 3 of these functions together, to including .plot, to go ahead and plot that very quickly. So here you can see it's very smooth. In fact, it's almost like a straight line in some cases, but you still see the flat line behavior at the beginning of 2016's data. You can learn more about the frequencies, like I mentioned, the data, the different notations of frequencies in the documentation, as I mentioned. Here's a link to that to check that out. The next function, which I find very useful once again, is truncation. Truncation is like slicing the data into smaller parts. If we do .info here and look at this dimension of the data frame, you can see we have 2016, 2017 data, 731 entries with our daily data, and we have 1,500 columns. So there's quite a few different columns. Truncation allows us to, let's say we want only the June data from 2016. So the truncation function allows us to do .truncate, and there's two attributes, at least one, but sometimes two attributes telling the function to cut off data before and after a certain range. So you're basically slicing off, in this case, all the data before June 1st and all the data after July 1st. So if we run this and take a look at the plot, what we're going to see is just June of 2016 until July of 2016. So just the month of June has been kept in this data frame _June only. So this is how you zoom in, basically, if you want to think about it that way with time series data. So now let's dive into some other time series functions, which are a little more advanced. You can use them once again for various applications that are not often so common. I don't use these so often, but when I do, they're very useful. So one of them is .rolling. Rolling is to create a rolling window of data. Here you can see Panther Education Jerome, where with a window of 500, minimum periods of 500, centering equals true, meaning that these are attributes that are fine-tuning the way the rolling window works. Rolling, if you're interested in this, I encourage you to check out the function because you can learn a lot more about the attributes with more time than what we have here. But you can see that the rolling window function looks kind of similar to the resampling because it's smoothing out the data in a certain way. It is removing more outliers though, because the window is much larger than a single day. There's lots of cool things that are happening here, which you can use to basically remove noise from time series data. So now let's look at now that we've learned about time series data, we've been looking at examples of single buildings. Let's look at a bunch of buildings at once. What we can do is we can use the .columns function, the .string function that's chained upon that, and the .contains function, all of them, to figure out which of the column labels have the word wolf in them. And why is this interesting? Wolf is actually the name, as we mentioned, one of the sites. If we find all the columns with the name wolf in it, we will know that we have all of the buildings from that particular site. With this line of code, what we end up with is an array, which is a NumPy version of a list that has either true or false. Wolf is not in the middle of the data set. So here we see a bunch of falses because the wolf is not at the beginning or the end. But what we can use this array for is an input to the .loc function to select out the columns that contain wolf, basically. So if we run this line of code, what happens is we result in a data set here, which is a site example. I've created a new data frame. You'll notice that, yeah, all of the different columns start with wolf. So that means they're all from the same data set. There are 36 columns instead of 1,500 columns. So this particular location doesn't have quite as many buildings. So that we're going to use it as a subset to understand how to look at not large, but moderately bigger than one size groups of buildings. So let's look at the info.info. This is a really nice representation of the data frame to show you each of the column names, the number of non-null values, the data type, of course, floats over the course of the data types. And it looks like we have 731 entries, and all of these have 731 except the first one. Wolf Assembly Sally is missing a couple days. So there's a couple days of missing data for one reason or another there. Let's use .plot to look at this entire data frame. We're using an attribute here called subplots equals true. You'll see here in a second what that does. That essentially allows us to see all of the data, all of these columns from this data frame in their own little line charts. These are almost like what we call spark lines, so that you're getting a high level overview. It's not plotting all of the data on top of each other. It's showing you each of the buildings on their own. And this is nice because you can start to see some behaviors as you scroll down that are very similar. You can see, for example, a dip here, it looks like, of consumption from the buildings. Let's see when that is. End of the year, that's in December. Of course, people taking holidays for the holiday season at the end of the year, and that's consistent. So you're able to see patterns across all of the buildings when you plot them all like this. You can see the peaks and the troughs of the different line charts are relatively similar for some buildings. You can see some buildings, Joaquin here, Wolf Education Joaquin, that seem to have a little slightly different behavior, not as deep of the troughs, let's say. There's not as much reduction in energy, let's say in the off days of the week, like Saturdays and Sundays. All kinds of things you can look at. Let's look at the data. Now let's resample with monthly instead, just to see what we can see there in this type of subplot example. When you do resample monthly, you can see that the data we've removed a lot of the noise. This might be a little less of a useful plot in some ways because now you're removing so much of the signal that it's hard for us to find any patterns. But this is just an interesting visualization to show that you can use resample for monthly data as well. And I like to zoom in. I like to use truncate to see various areas of data that I think are interesting. So let's take a look at all the data just in 2017. So we're going to cut out all of 2016. When we do that, we can see that now the data set is similar to the one above, but it's only 2017. We're able to zoom in and see various behavior that's different. Once again, this notebook is just giving you an understanding of these different functions. What we'll look at in the upcoming videos and notebooks is something more applied to the context of the built environment analysis using this type of data set.